Alright guys, welcome back to our next section of notes for this unit. Continuing what we've been talking about with parallel and perpendicular lines. Today we're going into 4.2 and we're talking about specifically these different types of angles that we see when we look at these diagrams with parallel lines cut by a transversal. So I kind of mentioned this a little bit in the last video, but we're going to see that same diagram over and over again that we saw with the two lines being cut by transversal and then having 8 different angles. We talked last time about corresponding angles. Remember, those are angles that are in the same spot, and that will help us. And now we're adding even more types of angles to that so we can go through some of these problems a little bit quicker, and I'll explain kind of what that looks like later on. So day today is the second or the third if you'd like to add that to your notes, and the objective for today is we're going to use these different types of angles to solve for different measures and different variables that we're working through with these problems here. Okay, so with that in mind, let's dive into some of this here, a little review. Okay, same as always, I want you to take a second, I want you to pause your video, and I want you to sketch this diagram for me, and make sure you give yourself enough room to show all the different angles here. Okay, so hopefully you have this written down, and one of the things I really want to stress or emphasize here is these little arrows here on these lines. So as a reminder, that means that these lines are parallel, and I always need to look for those on diagrams because otherwise I don't know whether different line or different angles are going to be congruent or supplementary, like we'll talk about today. Okay, so with this diagram here, I see these two parallel lines cut by a transversal, and it's saying I want to identify all the sets of congruent angles in this picture. Okay, so if I look at this here, we'll start with angle 1. I'm just going to put a circle on that. I'm going to write this out to the side here. So we have angle 1, and it's asking what is that congruent to, or what angles in this picture are congruent, or in other words, have the same measure. Well, notice, first off, if I'm not even looking at the bottom angles, let's just look at 1 through 4. If I look at the top there, I know it's congruent to angle 4, because we've talked about that before. That's what we call vertical angles. So that is congruent to angle 4. All right, are there any other angles? If I'm looking at this whole picture, are there any other angles that I know 1 is congruent to, or 1 and 4 are now both congruent to? Well, if I look at this here, if we use what we talked about last time, remember we said the corresponding angles, or the angles that are in the same spot, are also going to be congruent. So in this case, if I'm looking at angle 1, the corresponding angle to that would be angle 5. So I know all 3 of these are now congruent. 1 is congruent to 4, and 1 is congruent to 5. And so 1, 4, 5, they're all the same measure. And then last one here, if I put congruent as well, I could use multiple ideas here, but one that I could see is that 5 and 8, if I look at the bottom half, 5 through 8, I can see 5 and 8 are also vertical angles, which means they're also congruent. So with this, I have 4 different angles that are all going to be the same thing. I know they're all going to have the same measure. If one of these was 100 degrees, then all 4 of them would be 100 degrees here. Okay? Now looking at this, are there any other angles that we could kind of set up the same kind of thing here? Well, let's keep going and let's just look at 2, for instance. I'm going to write this out to the side. Angle 2, is that congruent to anything? And if we use the same ideas that we talked about on the previous angles, I see 2 and 3 here are going to be congruent because those are also vertical angles. So I could say this out to the side. 2 is congruent to 3. Okay, but like we've said, I know that's congruent to other things as well. 2 and 6 are corresponding angles. They're in the same spot. So that means that 2 and 6 are also going to be congruent. And remember, when I say in the same spot, I'm saying if I look at the top 4 angles here, I see 2 is in the top right. If I see that same thing with the bottom 4 angles, 6 is in the top right as well. And so those would be corresponding. And then lastly, is there anything else that's congruent to 2 and 3 and 6? Well, notice 6 and 7 are vertical angles, so I could say that those are also congruent as well. So notice here, when I see a picture like this, and I have 8 different angles, really, when they're parallel lines cut by a transversal, there's really only 2 angle measures that are going to be the options here. So for instance, if angle 1 is 100, then the rest of those 4, 5, and 8 are all going to be 100. If angle 2 was 80, then 2, 3, 6, and 7 are all going to be 80 as well. So even though there's 8 different angles, there's really only 2 numbers that would represent the measures here with all these. Okay, so something to keep in mind as we see these diagrams more and more. Okay, so with that being said, like I said, we have corresponding angles. Now we have some other ones that we can kind of add into this as well. And these are a little bit, I would say, easier to understand because it really just talks about the placement of them and where they're at here. So first definition we're going to write down, I want you to write down with me here, is going to be alternate interior angles. Okay? And alternate interior angles are this, or in other words, this is what we know about them. We could say if a pair of angles, are on opposite sides of the transversal, if a pair of angles are on opposite sides of the transversal and on the inside of the parallel lines, then, so you just have to write all that. I know it's a little wordy. If a pair of angles are on opposite sides of the transversal and on the inside of the parallel lines, or in between the parallel lines, then they are congruent. Okay, so this is information that I now can kind of use as I work through some of these problems here. If I see alternate interior angles, I know that they're going to be congruent. Okay, well, what does that mean specifically if we're kind of breaking this down here? That first word alternate is just telling me where they're at in terms of the transversal. So if I go back up to our first example here, remember we have our parallel lines. I'll erase these here. We have our parallel lines, and then the transversal is that line that kind of cuts right down the middle. And notice on one side of the transversal I have 1, 3, 5, and 7, and on the other side I have 2, 4, 8, and 6. So if it says alternate, I'm looking for two angles that are on alternate sides, or the opposite side of that transversal. So for instance, 3 and 4 on opposite sides, or 1 and 8, or so on and so forth. Okay? And then alternate interior is saying they're on opposite sides of the transversal and they're on the inside of the parallel lines. So for example, if I want to use examples from this diagram that we just drew, if I look at angle 3 here, I see that is on the inside of the parallel lines. I'll use a box to stay consistent here. Okay, we have angle 3. That is on the inside of the parallel lines. I'm looking for another angle that is also on the inside, or the interior of the parallel lines, and it's on the alternate side of the transversal. So in this case, we only have one option here for alternate and interior, and that would be angle 6. So if I see a picture like this and I was only given 3 and 6, I now know that 3 and 6 are congruent. And that matches up with what we said earlier when we did that review. Okay? And then what would be another example here? Well, I see angle 4 is also on the inside of the parallel lines. So if we're saying what is another angle that's on the inside of the parallel lines and is on the opposite side of the transversal, that would be angle 5. So I could say angle 4 is congruent to angle 5 because they're alternate interior angles. Okay, so this is just a shortcut that I can use. So now I don't just have to rely on corresponding angles. I now have another type of angles that I can talk about. Okay, and then with a similar idea, we also have alternate exterior angles. So I want you to take a sec, and I want you to write that down for me. Get the light turned back on here. Okay, alternate exterior angles. We say this. We said if, here I'll move myself out of the way here. Say if a pair of angles are on, same thing as before, on opposite sides or alternate sides of the transversal, and in this case, on the last one we said interior, so that was inside the parallel lines. Since it's exterior here, we're going to do the opposites, the outside. So on opposite sides of the transversal and on the outside of the parallel lines, if I saw these here and I had a pair of angles that are on opposite sides of the transversal and on the outside of the parallel lines, then the same conclusion can be said, then they are congruent. So this is another shortcut that we can use now, another type of angles that we have. Then they are congruent. Okay? So if I want an example of this, if I'm looking at that original picture here, let's go back. And if you'd like to, you can go ahead and pause your video and you can kind of test yourself and say, okay, what would be a pair of alternate exterior angles in this picture? Okay, if you want to pause your video, go ahead and do that now. All right, but otherwise, if we're looking at this here, let's just start with angle 1, because this is on the outside, right? This is outside of the parallel lines. If we have this here, what would be an angle that is also outside the parallel lines, except on the alternate side of the transversal? In that case, or in this case, it would be angle 8. So what I would say here for an example is I could say angle 1 is congruent to angle 8. Alternate exterior. And then lastly, what would be another pair? Well, I see angle 2 is also on the exterior of the parallel lines. So what is another angle that's on the opposite side or the alternate side of the transversal and on the exterior or outside the parallel lines? In that case, that would be 7. So I could say angle 2 is congruent to angle 7 for that same reason. All right, and like I said, this helps because then now we have these shortcuts where I don't have to worry about just looking for corresponding angles or some of the other types of angles we've talked about, but now it's just a little bit more of a shortcut here. Okay, so let's practice this a little bit and kind of look at some problems that we would see these being used in. So I'll scroll down here. I have example 1. I want you to take a sec and I want you to pause your video again. I want you to sketch this diagram because these diagrams are going to look a little bit different. Okay, so hopefully we have this written down with everything labeled. Notice again we have these arrows here to tell me that these lines are parallel. In this case, it's not the same kind of diagram as the one we saw on our review problem. And it's saying if the measure of angle 1 is 7x minus 15, and if the measure of angle 5 is x plus 57, first of all, what type of angles are they? What do we call those? And then what is x, or how would I solve for x? So first thing I'm going to do here, since we were told this information, you can go ahead and do this on your diagram as well, is I'm just going to label in the information that we have. So we're told angle 1 is 7x minus 15, so I'll go ahead and label that. And then we're also told angle 5 is x plus 57. Okay, and if we're going to solve these kinds of problems, I'm going to ask you guys the same questions over and over again. First of all, what type of angles are they? So if I'm looking at, don't worry about anything else except 1 and 5. All the other angles don't really matter here, because 1 and 5 are the only ones that I'm given information about. So I'm looking at 1 and 5, and the question is, what type of angles are these? Well, I see they're on alternate sides of the transversal, so I'm going to say alternate. Okay, and then the question also is, are they on the inside or the outside of the parallel lines? Well, I see the parallel lines are here, and both of them are outside it. So I'm going to say alternate exterior angles. Okay, that's the first question I always need to ask myself and I always need to answer. What type of angles are they? These are alternate exterior angles. Now the second question is, how can I use that to solve for x? Well, if I look at this here, I'm given these angles in terms of x, and I know since they're alternate exterior angles, if I look back at what we just wrote, then they have to be congruent. Then they are congruent. So what I can say here is that 7x minus 15 is congruent to, or in other words, equals x plus 57. So that's exactly what I'm going to do. If two things are congruent, I can just set them equal to each other. 7x minus 15 equals x plus 57. All right, similar to the kind of problems we saw with corresponding angles. And now we can just solve like normal. So multiple ways we can do this here. I'll just deal with the variables first. So we have a positive x. I want to subtract that from both sides. So when I do that, I get 7x minus x equals 6x minus 15 equals 57. Okay, continuing here, I have a negative 15 that I want to get rid of, so I add 15 to both sides. When I do that, these cancel, leave me with 6x. And then I have 57 plus 15. I could just type this in my calculator if I don't know, but that would be 72. And then last step here, we know, is to divide by that number in front of the variable. So divide by 6, and I get x equals 72 divided by 6. And I can just, again, type that into my calculator if I didn't know. Now I get x equals 12 here. All right, so x equals 12 is my final answer, and then we're always getting in that habit with geometry, just double check. Do I need to plug that back in for anything? In this case, it was just asking us for x, so we are good here. All right, so like I said, we're just going to go through that same process again with different types of angles. Is what type of angles am I looking at, and then how does that help me set up the equation? All right, so that is some of the types of angles that we have. We have others to add here as well. So instead of looking at alternate, let's say we're looking at same side angles here. So same side angles. So first one I want you to write down with me here, same side interior angles. Okay, same side interior angles, it says this. It says if two angles are on the, instead of opposite sides, now we're saying, like the name suggests, on the same side of the transversal. If two angles are on the same side of the transversal and, in this case it's interior, so we're going to say and the inside of the parallel lines, okay, then they are, and this is going to be different from what we've seen before. We said the last two, they were both congruent. In this case, if we see something with same side interior angles, then they're what we call supplementary. Okay, same side interior angles are always going to be supplementary. So they're on the same side of the transversal and on the inside of the parallel lines here. All right, so for example, if I was looking at that original problem that we've seen, that original diagram here, I'll erase these again to kind of visualize this. So in this case, if we're looking at that transversal, we're looking for two angles that are on the same side now, and in this case, we're looking for interior. So if I look at angle 3, I see that's on the inside of the parallel lines. And what would be the other angle that's on the inside as well and is on the same side of the transversal? In that case, this would be angle 5. Okay, so 3 and 5 would be an example of same side interior. And notice in this case, we're not saying they're congruent, but we're saying they're supplementary. Okay, and the same idea here, if I'm looking at angle 4, that's also on the inside of the parallel lines. What is the other angle that's on the inside and on the same side of the transversal? That would be angle 6 here. So angle 4 and angle 6 would be another example of same side interior angles. All right, and then lastly, last type of angles that we have to include, you can kind of guess what this definition is going to be. Same side exterior angles, and it says this. It says if two angles are on the same side, so similar to what we just wrote, two angles are on the same side of the transversal, and in this case, since it's exterior, we're going to say the outside. So we're going to say and the outside of the parallel lines. If we have two angles now that are on the same side of the transversal and on the outside of the parallel lines, then same conclusion as before, then they are supplementary. Then they are supplementary here. So if you want to kind of test yourself and see, if we look at that diagram, like I said, that we've been looking at throughout these notes, if I see same side exterior angles here, you could pause your video if you'd like to kind of test yourself. But in this case, the angles would be, if I'm looking at angle 1, that would be linked up with angle 7. It's on the same side of the transversal and it's on the exterior of the parallel lines. So 1 and 7 would be same side exterior, and then angle 2 and angle 8 would also be a pair of same side exterior angles as well. And notice the conclusion on these is different. In this case, instead of saying they're both congruent, we're going to say both conclusions that they're supplementary. Okay, and that's what really this chapter, or a lot of these kinds of problems, comes down to, is either they're congruent, which means you set them equal to each other, or they're supplementary, which means you add them up to 180. Okay, if we have a bunch of different types of angles, how do I remember all these? Well, an easy way to remember is if you see same side starts with an S, so does supplementary. Okay, same side, if I see that name, same side interior or same side exterior, then they are going to be supplementary. Okay, anything else, whether it's alternate interior, alternate exterior, or corresponding, those are all going to be congruent. Okay, so just a memory device or a way to kind of remember that. If you see same side starts with an S, same thing as supplementary. All right, so let's work on some problems here, practice this a little bit. All right, next one. I know there's a lot of writing and a lot of diagrams, but I do want you to sketch this for me here. Let's say we're looking at this here. I'm sorry, pause your video, make sure you sketch this. I'll give you a sec to do that. Okay, so we have this here. We're saying the measure of angle 3 equals 4x plus 16, and the measure of angle 4 equals 5x plus 2. And the question is the same two questions as before. What type of angles am I looking at here? And then in this case, we're asking what is the measure of angle 4. Okay, so if I'm looking at this here and if I have this written down, like we said on the previous one, I don't really care about any of the other angles besides the ones that I'm given information about. So in this case, 3 and 4 are the big ones that I want to focus on. Everything else really doesn't matter. So I'm just going to cross all these out or kind of block these out. You guys don't have to do this, but it's just helpful to be able to zone in on those angles that we're working with here. Okay, so I see this with angle 3 and angle 4. First question I need to ask is what type of angles am I looking at? Or are they? So if I see angle 3 and 4, well, first off, are they on alternate sides of the same side of the transversal? In this case, they're on the same side. So I'm going to say same side here. And I do want you to write this with me here. And then the next question is, are they on the inside of the parallel lines or the outside? In this case, they are on the inside or they're between them. So that would be interior. So same side, interior angles. Okay, so that's the first question it's asking, what type of angles am I looking at? And the second one is, what is the measure of angle 4? Or in other words, how would I set up an equation to solve for x and solve for the measure of angle 4? Well, notice we see this same side designation or this name, so that tells me that these two angles are going to be supplementary. Also starts with an S. So what can I do, or what does that mean if they're supplementary? That means they add up to 180. So I'm going to do exactly that. I'm going to say 4x plus 16 plus 5x plus 2 equals 180. Okay, later on we will work on setting up proofs for these and solving them that way, but as of right now, all you need to do is just know how to set up the equation. In this case, we added up to 180. And now once I've got this, I need to solve for x. So we'll continue here. I see I have terms on the same side of the equation that are the same type of term, so I can just combine those. So 4x and 5x, I can just add together to give me 9x. I have 16 and 2, I can just add those together to give me 18. And then this equals 180. We'll continue here. Okay, continue. We have a positive 18 we want to get rid of on both sides, so we subtract it. So when I do that, these cancel, leave me with 9x here. And then 180 minus 18, we could type this into a calculator if we don't know. That's just 162. And then last step here, divide by 9 to get x by itself. And we get x equals, again, you could type this into a calculator if you'd like, but in any case, 162 divided by 9 is going to be 18. So final answer we get for that is x equals 18, and then we're always using that habit or getting into that habit of checking and seeing, do I need to plug this back in for anything? In this case, I do. It's asking for the measure of angle 4, so I do need to plug this back in here. So notice I was told the measure of angle 4 is 5x plus 2. So measure of angle 4 equals 5, and then instead of x, I'm just going to plug that in now. So plug in 18 for x, and then plus 2, and now we just need to simplify. Now we just need to do the math. So measure of angle 4 equals 5 times 18. That would give me 90. And then plus 2. So measure of angle 4 here equals 92 degrees. And that's the final answer that I want. Okay, notice I did pay attention to which one I plugged it back into because these two angles are not the same. I just know that they add up to 180. And that would help me if I needed to find angle 3 as well. Okay. We did have a third example as well, but I'm running low on time, so I won't worry about running through that. But this is just the basic ideas with these kinds of angles. And like I said, it really comes down to two things. Even if you're getting confused and you don't know how to solve these kinds of equations, the good news is you really only have one of two choices. Either they're going to be congruent, so you're setting them equal to each other, or they're going to be supplementary, and you're adding them up to 180. So worst case, if you're working on an assignment or a test or a quiz or whatever, and something's not making sense or you can't figure it out, at worst case, you'll get it right 50% of the time if you just set them equal to each other or just add them up to 180. Okay, so keep that in mind as we work through these problems. Okay, but otherwise, that is all for today. Rest of time, you have to work on the 4.2 homework for this. As always, if you have any questions, feel free to let me know. All right, thanks, guys.